Welcome back to week 8, and in video 4 I'm going to get into how structures are related to plate tectonics and also the types of stresses, strain, and features that we see. So just to remind you of the 3 plate boundaries, we've got transform plate boundaries like the San Andreas Fault, we've got horizontal movement, divergent, we've got the 2 plates pulling away from one another. And then at convergent plate boundaries, we have 2 plates colliding. In some cases, we have subduction happening. So compressional stress happens at convergent boundaries, plates are coming together. Tensional stress happens at divergent boundaries, where they're moving apart. And then shear stress happens at transform boundaries, where they're sliding horizontally past one another. So talking convergent plate boundaries, here you can see what we've got in the Pacific Northwest, Canada, US. Here's our convergent boundary. We actually have kind of all 3 in our neck of the woods, which is pretty cool, if you ask me. So convergent plate boundaries, you can see the 3 major types of convergent boundaries where we have continent-continent, ocean-ocean, and then ocean-continent boundaries. So when we have compressional stress at this location, we result in folds like anticlines, synclines, domes, basins, and then any of the asymmetrical type of folds. And we get the faults present as well, but only thrust faults and reverse faults. So those are the specific types of structures we see at convergent plate boundaries. Some of the rocks that we see, to kind of relate things back several weeks, we end up with lots of metamorphic rocks due to the compression, the high stress, and also the contact metamorphism around these magma plutons. We get igneous rocks due to subduction, creating those volcanoes. And then anywhere we get a basin forming, like out in the ocean here, we can get some sedimentary rocks forming as well. So at divergent plate boundaries, or plates are pulling away from each other, we have tensional stress. And in these locations, like we have along the Mid-Atlantic Ridge, is a divergent plate boundary. Also, if we look at Africa, up here in the Red Sea, this is a divergent plate boundary, 2 plates pulling away from each other, forming a basin where sedimentary rocks can be deposited. We also see, especially in our neck of the woods, and in the southwest part of the U.S., we have what's called the Basin and Range Province. And that's where we have tension pulling on the crust, and we have these normal faults happening one after another, creating those horst and grabens. So we get normal faults and we get horst and grabens along these divergent boundaries. So we can get sedimentary rocks in the basins, like I mentioned, and where we have the grabens, and in our Red Sea area, and we get igneous where we have the magma rising up to the surface, forming the new crust at those divergent boundaries. And we can get metamorphic rocks where we have that magma coming up to the surface. And then our last boundary, transform boundary, this is where we get transform faults developing because of that shear stress that's present. We can get some sedimentary rocks starting to form, like along some of these boundaries we get these big long fractures. Sometimes we get lakes that correlate to those boundaries as well. So we can get sedimentary rocks building up in those basins. And then we can have metamorphic rocks along that boundary because we have lots and lots of shear stress present to be able to metamorphose those rocks. So we see offset fences and things like you see in that picture. So it's kind of a review of everything, kind of tying in rocks and plate boundaries to one another. So hopefully you guys have a good idea of some of the major geologic structures. You can also count types of volcanic landforms in the structure category. Some people do that as well. So just to show you our neck of the woods, we've got a pretty complex area, subduction zone, compressional stress, folds and faults, volcanoes as well, divergent along the Juan de Fuca, where we've got the tensional stress, and then we have shear stress along these transform faults and boundaries. So I hope that you guys now understand structural geology. Check out your book, great figures, and I'll see you in lab.